Hello everyone, and welcome back to Biopedia, guiding you through different biological concepts, sources, or people one at a time. In the ideal world, antibiotics act to kill bacteria, no further questions. But, as we are now aware, this is far from always the case. Antibiotic resistance is a widespread phenomenon that's set to cause serious problems in future decades. However, resistance is not the only way that bacteria have of fighting back against our formerly superweapons. Enter persistence. Persister cells are not outright resistant to the antibiotic being administered, but instead are able to temporarily withstand the drug and enter a state of dormancy until it is passed, at which point they can reproduce and the colony grows again. However, it's interesting to note that the cells their replication produces are not themselves persistent despite their persistent parents. Parents in big air quotes here. Also, unlike resistance itself, persister cells are genetically no different from the susceptible cells they outlive. These persisters may be able to survive single or multiple antibiotics administered at once, but they are phenotypically identical to their neighbours who perish from them. If an antibiotic is administered and a graph is plotted of live cells over time, a so-called biphasic killing curve emerges, whereby the susceptible cells die first and rapidly with a steep curve going down. The line then flattens off once only the persister cells remain, which die more slowly because of their tolerance. In effect, these bacteria are weathering out the storm and lying dormant until favourable conditions return when the antibiotic is removed. One technique for identifying persister cells is by using fluorescence dilution. This involves tagging part of the bacteria with a set amount of green fluorescent protein and observing it under the microscope. Because no additional green fluorescent protein is added in after the start, active cells slowly become fainter as the GFP is diluted out while they divide. By contrast, persister cells, which do not replicate, stay as bright as ever. The metabolic activity of persister cells is slower than their susceptible counterparts. This is because they enter a state of dormancy and reduced activity until the antibiotic is removed. This reduced level of activity has been shown to be important. One study found that if persister cells were stimulated to artificially increase their levels of activity again, by adding sugar to an antibiotic treatment, the cells were in fact susceptible once again. So, what is it that causes these reduced levels of activity? Toxins are, as we know, a big part of infectious disease. However, they have also been found to have an impact on persistence. Specifically, this refers to toxins which are also bound to antitoxins, molecules which impair them from carrying out their function and damaging the cell. This so-called toxin-antitoxin complex is self-regulating. The levels of the antitoxin present dictate the levels of transcription which create the system, for reasons we're going to explore in a second. The antitoxin prevents the toxin from causing any damage within the cell. Starvation or other stresses can, however, cause the antitoxin to be degraded. This frees the toxin, so to speak, and allows it to cause damage or interrupt vital processes within the bacterial cell, such as DNA replication and protein synthesis. Too much of this activity would, of course, kill the cell, but at certain levels it induces dormancy rather than death. If toxin activity is controlled by the antitoxin and the toxicity is not allowed to get out of control to the point of death, persistence can be induced. Persistence can either be triggered through adverse conditions such as starvation and immune system factors, or spontaneously appear when the bacteria are growing and dividing. One example, cited in a 2017 review paper, is that bacterial Salmonella enterica, specifically of the strain Tryptophinium, had a higher proportion of persister cells if the bacteria were placed inside macrophages for 30 minutes before the antibiotic known as cefotaximine was applied. This was down to the acidic and biologically stressful conditions the bacteria experienced, thereby triggering the degradation of the antitoxin and the subsequent emergence of persistence. Either way, persister cells are a problem in clinical terms, as they mean that infections can reappear even after a round of antibiotic treatment. There is the possibility that lowering the dosage of antibiotics every round of treatment would reduce the number of persister cells over time, but regardless, they remain a problem that's set to remain relevant in years to come. As always, thanks for listening to Biopedia, and I hope you've enjoyed the show. We can be contacted at biopediapodcast@gmail.com. That again, biopediapodcast@gmail.com. If you have any questions, want to suggest a future topic, or simply say hello. Thank you again for listening, and until next time.